Okay, so I am Pilar Piñeiro, machine learning engineer. I work with my amazing team that I wanted to present first of all. We are a very international team in Redstore. We are working from all over the world, Ukraine, Barcelona, Madrid, South Africa, and Malaga. We have 2 machine learning engineers in the team, a deep learning expert, and we have a data scientist that recently joined us, and a machine learning operations engineer. On our day-to-day, we build solutions, run POCs, research, all types of things that we can implement for the different products that Redstore wants to offer. So what I'm going to show you, what my main idea is to explain one of the projects that we worked on, which I think is the most challenging that we've worked on. We've worked in different projects such as, well, I'm going to briefly explain it later, but I chose the most challenging one because this project can teach us some lessons that I think maybe you can apply to your personal projects. So, you maybe won't see much, but this is the problem that we were faced with. Redstore wanted to offer their customers a product that would help them get some insight on the backup data that we have and that falls under the GDPR regulation. And they wanted to evidence compliance easily, and that's what they needed. They needed to have a product that would tag their documents according to the sensitivity level. As you can see, probably in the other screens, this is a mock-up of the final product, and the idea is that we would get a tag assigned to each of the files according to their sensitivity. That way, then the client would decide if they wanted to take some further actions on this specific document. So, what was the main problem, or what did we have to implement? We had to implement a model that was able to classify these documents in highly sensitive, sensitive, or non-sensitive categories. Let me give you some examples of what non-sensitive document would be. This is a text that has no data subject in it, so there is no name and surname indicating identifying a person, and there is no information about them, so this document could be considered as non-sensitive. This document, per contrary, it has a name, race hopper, and this identifies a data subject, and additionally there is some additional information in it that may be considered sensitive. It's a passport, and additionally there is also an email address. So our model had to be able to label it sensitive. But of course, Redstore did not want us to see the data of the client in any way. So we needed to assure that we were not going to have access to any of the data from the customer. This represented a very big challenge because we did not have data to work with. And this was the first of the challenges. Redstore agreed to share a couple hundred documents that they held and that they helped us classify according to the sensitivity. But that was all. The second challenge that we found was that once we collected the documents, we needed to label them manually. And it's not a simple task, as you can imagine. There may be hundreds of words in a document or thousands, and you need to know if this is a name, if there is additional information about this person that might be considered sensitive. This had to be done by a person or a lot of persons. And additionally, there was a third challenge that was we needed to extract this text from the documents. And the documents, it was not actually a challenge at the beginning, and one would say this is the easiest part of the problem, but there's not an issue. There are many tools that can do this. But when we got to that stage of the development, we found that it was not a simple task because there are many tools, but the text extracted from the tools is sometimes very messy, and it's not useful for inputting to a machine learning model. Fourth challenge that we had was that, as I said, the text was messy. It has a lot of noise, and we had to work a lot on it. As you can see, all of the challenges that I talked about are about data. And I wanted to emphasize this in this talk because this was all about data in this project. What I'm going to present is the classical pipeline that machine learning project follows. Initially, I'm going to I already talked about the problem, but then I'm going to talk about the data, how we generated it, and how we processed it. And after that, I want to talk about which models and which experiments we conducted. Also, I have created a small demo that I'm going to show you. And the evaluation results. Then after that, we can maybe go over the most important ideas and what lessons we learned with it. So, for data generation, what did we do? Of course, you can imagine synthetic data, right? So, our first shot was generating a synthetic dataset generator, which consisted in, first of all, extracting non-sensitive data from different wiki pages that had keywords related to the GDPR regulation. That could be any IDs, passports, names, surnames, date of birth, gender, you name it. And for sensitive and highly sensitive data, we had our team help us generate sentences, and we would embed with a library named Faker all these different types of passports, names, countries, anything. And that was going to give us our synthetic dataset. The good thing about this approach was that we were able to know the location or where we were going to embed these texts, and we could then easily label and classify this data for downstream training. But there was a drawback that probably you already imagined, that is that these sentences were probably very similar one with each other, and the model was going to probably learn these patterns, and these patterns will be very different from which real documents will look like. And this was the case. So after deciding to give it another shot, we decided to do what we didn't think was possible or that was doable. That was having a lot of people download documents from all over the internet and fill them with fake data. And this is what we did. We had people collect documents from political party websites, hospitals, universities, kindergarten, anything. And then we had these people fill them with fake data, but additionally we had them classify them manually in folders. Additionally, we asked them to record the data subjects, the names and surnames with which they were filling these forms, because later we would be able to label our documents with the position of the data subject. It would be very useful for training what are very well known as name entity recognizer models, which I'm going to explain later. So here's a table to show the variability of documents that we collected. This was the initial collection when we started with the modeling. As you can see, there were many types of documents that we collected, mainly doc and PDF. And I wanted to show the different types of documents that we use because I wanted to see the difficulties that represented the text extraction. As I said, this was not a difficulty until we did it. And we found out that we needed to iterate a lot on this. Apache Tika is an open source tool that is very useful for text extraction. It can extract text from pretty much any file. But PDFs are very tricky. PDFs have many different formats and different ways to store fill-in data, mainly forms. And we found out that most of the times the form text extraction would show the text filled in manually at the bottom of the text. So we wouldn't have the fill-in information in line with the rest of the text, and this was a problem for us. That's why we decided to explore more, and we found that Textract, a Python library, is very useful for this. It is able to extract the fill-in information in line with the rest of the text. And after doing some iterations, we found out another issue that was that sometimes filled-in data in PDFs cannot be extracted by any of the tools, so we need to use OCR. And this is more like a trade-off between the quality of the text and the speed that we needed in extraction. So we needed, as I said, to iterate many times through this, and we are still optimizing it. So we had the data, and now we could get started with the model implementation. The thing is, usually data scientists tend to jump right into the implementation of the latest model, the most edgy and state-of-the-art. But from my experience, I would recommend always start from baselines. Baselines are great because they provide 90% of the value for 10% of the effort. It's much better to get a model that can perform with 80% accuracy in 2 days than a model that can do well and apply give you 85% in 4 weeks. When you're working with clients, it's important to know this. And additionally, baselines also give us some starting performance to compare our next models, the more complex models that we use, to this baseline. So for baselines, we used 3 different approaches. The most basic one, the most simple one, is a rule-based approach, and it was based on keywords, and these keywords were based on the GDPR definition. Our second approach was an existing solution that we explored, and it was Presidio by Microsoft. This solution is an anonymizer of text, and it can detect entities in the text and replace them by the name of the entity. Presidio is based on a name entity recognition model, which is able to identify in the text the entity and assign it to a predefined category. For example, James is in Spain, would be detected. James would be detected as a person, and Spain would be detected as a location or a country. And the exact position will be identified as well. And Presidio additionally has some regular expressions built on top. So we decided, okay, we already have an implemented solution, we can try this, and maybe we have finished. But it turns out it gave us a lot of false positives for our situation. So the third baseline that we tried was a very basic classical model. For a classical model, you need a tabular data, and we conducted a feature extraction in which we used the 2 baselines that I mentioned. Those keywords were some of the features, and additionally we conducted the FIDF feature extraction, and these were the features used for this classical machine learning model. All of the 3 were going to be our starting point, but from them we decided we could start exploring new solutions. So our next idea was, okay, name entity recognition models, this seems like the best solution for our problem, because We need to detect passwords in the text, we need to detect names, and we said, okay, let's try this. And we used spacing library and Hugging Face and Transformers library to fine-tune pre-existing models. These models are pre-trained and allow to fine-tune them with little data to reach state-of-the-art results. But we had a problem here, and was that to fine-tune we needed to label all the documents that we were filling. This was a very time-consuming task, and it was not doable for the time being, so we decided to discard this option. Next, I want to mention Spacey Text Categorizer, among other libraries that we tried. Spacey allows to easily prototype an NLP solution, and it's very convenient and easy to use. Also, it has a lot of architectures to try. But the problem with this is that it allows very little customization, and we needed more flexibility. This is why we decided to start training more complex models, and this is where we started working with BERT, convolutional neural networks, gated recording unit, and long-term memory. We decided to experiment with all different architectures, and after all these combinations, we decided, okay, we are trying single models by themselves, but what if we combine them? What if we try to pre-process text with a naked entity recognition model and then feed it to a second model? And that's why two-stage models appeared in our mind, and this is what I want to explain a bit. So one-stage models is what you typically know. You have an input text, and it's labeled in one of the three categories. You train the model, you have your model trained, then for inference it's the same. You input your text, you get a prediction. For two-stage models, the idea was that we were going to, let's see if this works, process the text and label it for the first stage model, which was going to be a named entity recognition model. This was doable. I mentioned that labeling was a complex task, indicating the exact position of the data subject. But if we only did it for the data subject, it was a possible task. We were not going to label all the passwords, all the genders, but doing the data subject was a possibility. So we needed to indicate the position of the start and finish of the data subject. And this was going to be the input for our first stage model, which was going to train. Okay? So now that we have a first stage model, we could train a second stage model. But for that, we needed to pre-process an input text that was going to be pre-detected by the first stage model, which was going to replace the name for a data subject token. That was going to be the input for our next second stage model, together with the target, which was going to be one of the three: sensitive, highly sensitive, or non-sensitive. So, with all this, then we had the inference. How was it going to look like? So this is what it would look like. We would have a document, we would extract the text, we would feed this text to the first stage model, which would process the data and indicate where the data subject was found. And the second stage model would take that and give us a prediction. So all of these models, all these ideas were experimented with at the same time. So we built a pipeline that was easily configurable from a config file where we could select which models we wanted to try. And we could also select which type of data we wanted to load and how it was going to be labeled. This made it much easier for us to be able to run evaluation on all our models very easily with the same data. So here are our results. I thought you would be interested in looking at them. One-stage models show quite good results for the last two, simple convolutional neural network architecture and Distilbert. I did not mention that we decided to use the Distilbert variant. It is much lighter, faster, and also it has 93%, I believe, of the performance of BERT. So it was very convenient for us. For two-stage models, then, we chose to combine net entity recognition models as the first stage and these two base models from the one-stage model. And this is what we got. As you can see, the first four net entity recognition models were fine-tuned by us with the additional data subject. But we additionally wanted to try to compare with pre-trained models that were not fine-tuned by us. And as you can see, the performance was improved. I wanted to show a small demo of how one of these models works. The demo is using the simple convolutional neural network model. And let's see if I can play it. My idea with this was not only to show you the model itself working, but also I wanted to see the library that we're using that is very convenient for debugging black box models like convolutional neural networks that allows to easily explain how the predictions work. So this could be considered not even an MVP, but a POC, given that we didn't have any data and we had to start from scratch. And right now what we're doing is testing the models, optimizing them, but at the same time setting up an architecture and discussing if we can get insight in some way from the documents from the customers without being able to see them. And a good idea would be to have them help us label the documents, and on their side we could transform the data and then only get the vectorized information on our side. And that way we would assure that we are not seeing the data in any way. We are working on, as I said, the optimization of the models. We are using ONCs for that to make the model easily to make it easy to run the model in any device or platform, and also speed up inference. But as you know, machine learning is an iterative process, and we are going through in all of the 5 phases all the time. We are running some improvements in the feature extraction, as I said. We are also working on the modeling. We are evaluating. And performance analysis is something that we want to do. We are going to include some logging to be able to at least have some insight on the characteristics of the client's documents, such as size, counts of patterns that they have, anything pretty much. And this is an overview of the architecture that we have right now. This is, we have set up 2 services, one for the text extraction and one for the inference. We're using Kubernetes, and we want to be able to scale horizontally to match the demand. So this is what we are building. And, oops. Okay. So, to finish, what I want to do is go over the main lessons that we learned and maybe can help you in the future or in any project that you may work in. And they are, first of all, there's no standard approach. There's nothing that works every time for machine learning, and for data generation, even less. But baselines usually are a good way to start. Baselines not only have the advantages that I already said, but they have helped us find out the problems that we have in our generated data. We did not have to wait until we were in the middle of the model development to know that the data that we were using initially was not enough. And main entity recognition models can be a good preprocessing tool for downstream modeling. This was something that I actually didn't know, and After seeing our results, I started researching and I saw that it's very common to use entity recognition models to standardize text in medical field, in medical research field, focused in NLP. They usually standardize diseases or medicines which help them about other tasks that involve NLP. And I think it's important that probably most of you already know this. Sometimes when a company is very young in the application of data analysis, it's important to introduce the data culture in it. I think it's important that the team, AI team, is able to participate in how they are storing their data, how they are treating it, because it can save a lot of time when starting a new project, and also it can give new ideas for new projects. And this is something that we're experiencing right now. We are participating with the team and we are coming up with new project ideas that we will probably be implementing in 1 or 2 months from now. And finally, data collection is 80% of the work. You probably have experienced this. Sometimes it's even more if there is no data. But I think that it's something that happens every time, and we have to know that, and it's okay. But I wanted to make a point in this presentation, and probably you've seen something moving around the slides, and I just wanted to make a point because we never, ever stop collecting data during this project. And well, it's been great fun talking about this. Hopefully you have some questions that I can answer and we can discuss. And I really enjoy hearing what you are working on.